Good morning, students. Once again, now we are already understand the operations related with rows and columns. So, inverse of matrix by row transformation we have to consider today. So, to calculate the inverse of that any non-singular matrix, that means determinant is non-zero, by row transformations, following steps we can use. So, as far as that row transformations are concerned, you know that forms three types are there. So if we have to calculate the inverse of that matrix by row transformations, then only row transformations we have to use. So calculate first determinant of that particular matrix. Then use the definition of that inverse of matrix, means A into A raised to minus 1 equals to that I, where that I is the identity matrix of respective order. Then use only row transformations to both sides of equation to maintain the equality and convert that matrix A, which is to the left, into identity matrix. And you know identity matrix, if in multiplication with any matrix, then the result is that matrix only. Then at last we get the inverse of matrix to the right. That means identity matrix is converted in the inverse of that matrix. So for example, we have to consider A equals to 1, 3, 2, 4. So just given matrix point of view, now we have to calculate the inverse of that. So first we can calculate determinant. 4 minus 6 equals to minus 2. Now you can use the definition A into A raised to minus 1 equals to I. Now applying that operations, we want that identity matrix in the multiplication of that A raised to minus 1. So first just use only row transformation. So first one is R2 minus 3R1. That means we expect in place of 3, 0, and then after the remaining calculation. So as we use that operation which is given R2 minus 3R1, then changes in R2. So R1 is as it is to both sides, 1, 2, 1, 0. So now the result of operation is in the second row 0 minus 2 minus 3, 1. Now by using 1 by 2, but minus 1 by 2 R2, because we expect that 1 in place of that minus 2. So divide to both sides by minus 2, that means R2, or you can say minus 1 by 2 R2. So you will get 1, 0, 2, 1, 1, 3 by 2, 0 minus 1 by 2. Then next operation, in place of 2 we expect it is 0. So using that operation, it changes R1, R1 minus 2 R2. That means multiply by that constant 2 to the R2 and subtract from that R1. So 1, 0, 0, 1. Then after 1 minus, it becomes 3 because of minus 2 if we multiply. Then it is minus 2 and next one it is 1. So that remaining inverse as we consider. Now that 1, 0, 0, 1 is the identity matrix. So I into A raised to minus 1. That means only it is a A. So A equals to that minus 2, 3 by 2, 1 minus 1 by 2. So as we consider that 3 by 3 matrix, again same procedure, we can use that particular determinant 1 into bracket 24 minus 25 minus 2 into bracket 12 minus 15 plus 3 into bracket 10 minus 12. So at last calculated value it is minus 1. Now again you can use the definition A into A raised to minus 1 equals to I. Now you can put the value. Now as we have to convert that matrix A into identity matrix, now the first one operation R2 minus 2R1 means multiply by that constant 2 to that R1 and subtract from that R2. So it becomes to the left 0, 0 minus 1, second row, and to the right minus 2, 1, 0. Only look into the second row. Then next one, we have to consider that next operation, and that one it is R3 minus 3R1. So multiply by 3 to R1 and subtract from that R3 to both sides. So that R3 becomes 0 minus 1 minus 3. To the right, minus 3, 0, 1. Then just interchange that R2 and R3 because in identity matrix, as we know that elements, so 0 minus 1 minus 3, 0, 0 minus 1. To the right, minus 3, 0, 1, minus 2, 1, 0. Then after, just multiply to two rows, R2 and R3 by minus sign. So it becomes plus. So 0, 1, 3. Then next one, 3, 0, minus 1. Now, R3 point of view, 0, 0, 1 and 2 minus 1, 0. Then next one we can use two operations. Out of that first one, we have to change that particular form point of view. Just as we consider that value, then R2 minus 3R1. So, if we consider that value, then look into that changes. Then after R1 point of view, just we can use R1 minus 2R2. So, again that calculations point of view, definitely in the left 103, 0, 0, 0, 1, 0, 0, 0, 1 and to the right 7 minus 6, 2, minus 3, 3 minus 1, 2 minus 1, 0. Now in the next step, we have to just consider the changes in R1. So R1 minus 3, R3 and then next one, in identity matrix it is there. So to the right, the definitely value of inverse is 1 minus 3, 2, minus 3, 3 minus 1, 2 minus 1, 0. So as we consider that inverse of matrix, operations related with only row transformations we have to consider. So we will get the inverse of matrix. Practice the problems which are given in the text, means solve problems only. Thank you.